All right, all right, all right. How's everybody doing? Good. Woo! Everybody having a good reInvent? All right, great. Our session is COP321, Best Practicing for Operating on AWS. This is an hour-long presentation. We hope you find it very informative and you learn something or a few things. We're going to start by doing some introductions. My name is Steve Rice. I'm the General Manager for AWS App Config, which is part of Systems Manager, and we'll talk a little bit more about Systems Manager later.
Guilherme Greco, Enterprise Solutions Architect for AWS.
Thiago Moraes, Head of Cloud Platform at Banco Itaú.
Great. So let's do introductions. Everybody stand up and introduce yourself and give us a fun fact about yourself. Just kidding. So, but thank you all very much for taking the time to attend this. And again, this will be a series of best practices, some insights from a real-world customer, and things that you can take home and start using with your teams next week. First, I am going to start with a story. Does anybody know where this building is? Has anybody seen this building before? Shout it out if you have. It's in Montreal, Canada. Ooh, I see somebody in the back. Montreal, Canada. Do we have Canadians in the room? All right, I love Canadians. Canadians are some of the nicest people that write some of the nicest code. But also, I do want to say, I got to work with a lot of folks from Brazil, and I want to say obrigado to working with these. It was a great way to get to know this team. So, but I'm going to tell a story about something that happens to a lot of customers as they start their journey onto AWS, onto the cloud. They start by saying, you know, we're going to take one workload and we're going to put it on the cloud. We're going to create this single workload and we're going to create an account to manage that workload. And they set up that single unit. It's almost like a single apartment. And they get it working really well. They get it working so well, in fact, that they say we're going to put a second workload on there. It needs to be a little bit separate. It's a separate workload. We want a separate account. But we want to have some shared permissions. For security reasons, we need to segment, but also have some shared. So they'll build that second unit kind of on top of the first one. That goes very well, and another, and pretty soon you have developers in your organization spinning up accounts, and you start to build very organically. And your senior leadership asks you, wait a minute, seems like there's a lot of AWS accounts, a lot of structure, a lot of workloads. Is there a way to draw a diagram of how all this fits together? And what comes to mind is something like this amazing building that actually is very stable and perfectly designed on purpose. Looks a little chaotic unless you know what it is, but that's somewhat familiar for customers as they grow, as they scale on AWS. They start to build these structures, and they need to scale in order to operate at the levels that many of us need to operate at. So let me talk about what we're going to cover today. We're going to have three main sections. First, we're going to talk about laying the foundation on AWS. We're going to talk about some of the ways to do that and some of the best practices for doing that. We're going to talk about, after that foundation has been laid, how to operate at scale, how to make sure that your operations are streamlined. And then the third section is going to be Itaú talking about some of these insights, the ways that they've taken these best practices and how they've laid out their setup on the cloud. So I'm going to hand this over to you.
Thank you, Steve.
Greco, go ahead.
Okay. So as everybody knows, it is no longer a question if your organization is moved to the cloud, but how fast you can move with control, security, visibility, and safety. But before diving deep in operational excellence to achieve this, you have to define our foundation. So let me show to you common challenges that customers face to define their foundation in order to scale operations. Customers don't have a clear view on how they're operating in the cloud, but defining operating model in the cloud will allow you to have a clear separation of concerns in terms of application, infrastructure, and the platform team. This is the key for defining your landing zone, your multi-account strategy. Deployments are not fully automated, and there are a lot of dependencies between application and infrastructure team. It causes business areas to have the same time and process that they had on-premise to deploy at AWS. Developers don't have the ability to build and run their own workload because they did not receive a platform with infrastructure abstractions that can enable them to operate safely by themselves. Customers don't have a mechanism or a process to enable individual AWS services in their landing zone. They're blocking developers to use AWS services instead of focusing on controls that can enable the developer team to launch AWS services to solve business problem. That being said, let me go to best practices on how to address these challenges. And the first one is define your operating model. In order to explain or illustrate different kinds of operating model, I will show some 2x2 diagrams where we can explain the difference between how different teams can operate at the cloud in order to deploy and run their own workloads. So let's start with traditional operations. You can also think of this in an extension from on-premises until AWS. So if you are in the middle of lift and shift migration, this kind of operating model is perfect for you. As you can see, the application engineering team is supposed to perform deployments, and the operations team for applications is a fully separated team. If you compare to on-premises infrastructure side, instead of having multiple infrastructure teams like hypervisor, storage, and network, we have platform engineering team. But as application team, we do have a separated team to run and operate the platform. Let's see another one, decentralized DevOps. As you can see, the application team now is responsible for infrastructure, platform, and application. So they have their own compartment where they can build and run their own workload. They are customizing their infrastructure and their application. They are creating their own platform capabilities. So the platform engineering team has a different scope in this case, but with a reduced capacity, because the platform engineering team is now responsible to create accounts with security policies to delegate this to the application team in a way that we can prevent the application team to configure an AWS services that would expose the enterprise to financial, security, or operational risks. We call this model as decentralized DevOps because we have different teams building and running their own workload at the same time without dependency between them. So if you are refactoring your application, you are creating, modernizing your application, this kind of operating model is perfect for you to speed up your process. So let's go to distributed DevOps in this case. So you can see that the applications is still in charge of running, the application team is still in charge of running their application, but we have more responsibilities for the platform engineer team. We can say also that we have some kind of shared responsibility model between the application and the platform team, because now the platform team is supposed to create infrastructure abstractions that can be used by the application team to launch workloads. We call this as distributed DevOps because we have two perspectives, right? So the application team is running, building their application, and the platform team is doing the same. So if you want to standardize the way that you implement infrastructure, that we deploy infrastructure environment, or if you want to reduce the cognitive load that your developers have in order to deploy an application to AWS, this model is perfect for you. Okay, we talked about different operating models, but what could we do in our infrastructure to accommodate an operating model that I have decided to use? Here we go with our second best practice, align operating model with multi-account strategy. But before, let me explain to you what is an AWS account. An AWS account is just a logical compartment where we can separate resource, access, limits, and costs. Within the account, I can have compute, storage, and network fully separated from other accounts, even other AWS services. Steve mentioned about apartments. Yes, we can compare an account with an apartment in our landing zone. But while I'm increasing the number of accounts, while I am increasing the number of workloads, I have to organize them. And I can use AWS organization to help us. AWS organization is an account management services that allow customers to consolidate multiple AWS accounts into one organization in a way that we can manage this centrally. AWS organization has organizational units that can be compared to logical folders where you can accommodate accounts that have the same purpose. As you can see, you have a foundational U, when the security organizational units can support accounts responsible for logs, security, and the security tooling. The same for infrastructure, where accounts responsible for shared services and network can be located. On the other side, we have additional U's, or organizational units for workloads. In this case, an organizational unit for workload is supposed to follow the software development life cycle for your company, like development, production, and pre-production. We can also have OUs with ephemeral accounts that can be recycled and delivered as a sandbox compartment in the sandbox OU. So this is a long conversation. We have a lot of best practices behind of this. So this is the QR code that you can scan. You're going to be forwarded to additional information on how to structure organizational units. But I need to create something. I need to create my workload at AWS. What would be the starting point? So let's start defining a group of accounts or organizational unit that follows the software development lifecycle that I have in my company. In this case, just as a starting point, I'm showing dev, UAT, and production. Again, just an example. There are customers that use pre-prod, alpha, beta, gamma, so the number of accounts within the group depends on your definition. Okay, I have my group of accounts, but how am I going to separate them? Per project, per product, per team, per business units, per application. How many applications can I have in one account? Is it the best practice to have one account per application? What is the trade-off? So let's use the operating model to guide us in this kind of decision. So let's suppose that I'm just a product owner and I decided to use decentralized DevOps for my operating model. And in this case, an account with a single workload is perfect for me. And it totally makes sense because what I need is just a logical compartment where I can create my customized infrastructure with my customized application. But we do have some lessons learned here. If you are a large enterprise with thousands of applications, don't allow account to sprawl because having thousands of accounts, you deliver to you an overhead to distribute your controls at scale and you will fragment your infrastructure. And even more, not all of your applications will require customized infrastructure. Not all of your squads will adopt decentralized DevOps as an operating model. So based on this, consider using accounts with multiple workloads as a balance, but remember to define your landing zone in a way that can support different kinds of operating model. So let's see the other side, the other kind of operating model. For traditional ops and distributed DevOps, I can use accounts with multiple workloads. Because those kinds of operating model have a centralized team that is in charge of infrastructure and the platform. It avoids gray areas. And even more, the platform team can create logical boundaries between applications in the same account, like service meshes, VPCs, attribute-based access control using IAM. Again, another best practice or lesson learned, don't allow workload sprawl within the account. Having too many workloads in the same account will increase the scope of impact of that account, and it will increase the concurrency in terms of service limits for AWS services. So if I have a critical application and you want to land it in the traditional ops or distributed DevOps, you can also use dedicated accounts for it. Again, a lot of information. So this is the QR code. If you want to go into details in a framework on how to guide you in this kind of decision, you can scan it. Fine. Now that I have my operating model aligned with my multi-account strategy, I need to deliver my controls. So here's our third best practice: centralize your governance and deliver your controls. So we can do this at AWS using AWS Control Tower. AWS Control Tower is a managed services that allow customers to manage multi-account environments. With AWS Control Tower, customers can set up their landing zone, centralize identity access and logging, and automate compliant account provisioning distributing controls. So the platform team, for example, can take advantage of AWS Control Tower to launch compliant accounts with out-of-the-box proactive, detective, and preventive controls for the services that they enabled in their landing zone. Okay, but now I want to be more prescriptive. I want to show the steps on how to build an operating model showing the best practice that we discussed so far. Let's come back to the starting point about the software development lifecycle and the number of accounts that we created, the group of accounts. So the first thing is to have a separated compartment where I can perform cross-account deployment. I need this because your development tool is supposed to stay outside your environment. So now, the platform team can distribute standardized pipelines, service catalog products, or scaffolder repositories in that account. Again, this is just an example. I'm using code build, code commit, and code pipeline in service catalog, but you can have other AWS services like AWS Code Catalyst to create pivot paths. So now, the platform team can enable an AWS services, create infrastructure abstractions that can be exposed into internal developer platforms or even Git repositories with opinionated infrastructure templates like CDK constructs, Terraform modules, CloudFormation modules, or use Kubernetes control planes with other open source tools like Crossplane. Okay, I've enabled my services at AWS. I have infrastructure abstractions, but what about our controls? So the platform team can interact with AWS Control Tower to launch compliant accounts, ensure that all the accounts will have audit logs with CloudTrail, detective controls with AWS config, proactive controls with CloudFormation hooks, preventive controls with service control policies, or even using account factory customization to create customized blueprints to launch accounts, for example, using, with automated runbooks using systems manager automation. Okay, but we just talked about the platform team. What about the application? So the application team can have access to sandbox accounts in order to experiment and create idealization. So if they want to develop their code, they go to the development account. You can see AWS Identity Center. AWS Identity Center is a managed service that allows you to centralize identity access for the whole organizations. And in this case, developers can have access to Identity Center to directly interact with non-production accounts using console, CLI, SDK. But if the application team wants to push the code to UAT in production, so they can use the standardized pipelines that the platform team created. And in this case, using the same pipelines, they can launch the AWS services that were enabled using the infrastructure abstraction that is available in the internal developer platform or in the Git repositories. Okay, I can deploy in production, but what about operational tasks? So developers can have access to automation documents that the platform team created, or even more, they can delegate access to automation documents to operators in a way that we can enable them to do repetitive and operational tasks in production without even access the environment. As you can see, we could build an entire operating model using the software development lifecycle that I created, and I used the 3 best practices that we discussed so far. Now, it's time for a short demo, and I'm going to demo a decentralized operating model. Okay, so I'm logged in Identity Center. And in this case, I'm just playing that I created a centralized operating model. And right now, I'm from the platform engineering team. So my role in this case is to enable S3 as a service in my environment. And since I'm using the centralized operating model, I have to delegate accounts to developers. So the developers will have their own infrastructure templates. But I want to prevent them to create, for example, an S3 bucket with an S3 bucket policy that allow non-encrypted traffic. So this is my control. So I go to Control Tower. Let me show to you, this is the same landing zone that we discussed, right? So I'm just following the software development lifecycle from my organization as a starting point. So we have a UAT, OU, production, and development, and I have the accounts under this. So I need to enable S3 bucket, right? And I'm going to use out-of-the-box controls for Control Tower. So using the console, I can search for S3, go to behavior, proactive controls, and here's the control out of the box that I can enable in my organizational unit. I've done this before, okay? But as you can see, we have the control enabled in that organizational unit that was passed to the account, to the production account. So, okay, as a platform engineer, I deliver the control, and now my developers are able to launch using their own code, their own template, S3 buckets. But remember that I have controls, right? So let me switch now to a developer role. I'm a developer. I have my template. This is just a simple CloudFormation template with 2 resources, 1 bucket and another bucket policy, right? Pretty much simple. And here's the condition that allow me to send non-encrypted traffic. And the platform team doesn't allow me to do this, right? But I don't know. So I'm just logging into Identity Center just to simulate a pipeline, right? So in a real world, as I mentioned, you are going to use pipelines, but just for them, I'm just simulating this. Okay, I'm logged. And now I just created a shell script to deploy my template that is not compliant. Oops. Firstly, I have to remove the stack. Okay, the stack was removed because I had deployed this before. And now I'm deploying this. Okay, so I'll come back to the production account. I can see the stack being created here. So let me go to the events. And as you can see, this is the first event related to the first resource, that is the bucket, right? So the bucket is going to be created because I don't have controls on this. I want the developers to create that. And then CloudFormation will pass to the bucket policy that will trigger the CloudFormation, the control that I distributed with control tower. And in this case, the control is just evaluating the code that I created, and it should be blocked. Yes, it was blocked, and here's the reason that it was blocked. So I have the ID of my controls. So I could, as a platform engineer, delegate accounts to a developer, and at the same time, I use it out-of-the-box controls that can prevent developers to launch something that does not follow the compliance from my organizations. Okay, now I will switch back to the presentation, and I will hand over to you, Steve.
Thank you, Greco. Great. So once that foundation is laid, and I can't stress enough how important it is to get that foundation right, because you're going to build on top of it. We're going to talk about what it means to operate on the cloud at scale. So you need to have that foundation in place. It's almost like you're building that city, and you need to have the building flowing well, to have all the plumbing and the air conditioning and all that needs to be set up correctly. So at AWS, we have sort of 4 questions that we ask about in terms of our operating model, about how we operate our services. We look at our ops pain points and make sure that we are prioritizing them. We often ask ourselves, how can we scale up? 50%, 100%, 200%. Where do we have repetitive tasks? I'm going to talk a little bit about automation. And then how can we improve resiliency? That's so important. We always say at AWS, the most important feature we have is security. The second most important is availability. And third is whatever the service does. And so it's super important that you ask yourselves these same questions that your operations teams, whether it's centralized or decentralized, are asking themselves. So the first one is treating operational pain points like a feature backlog. You'd be surprised how often we talk to customers that don't do this. This is tech debt that just never gets done, and because there's not really a structure in place to do it. So the first thing to do is to identify those operational pain points, make sure that you prioritize them. What we use is a scale that has different inputs, and the inputs are sort of, how much is this going to improve the on-call's life? Does this affect customers? Is there a security risk, an availability risk? And how easy is it to implement? So we have a weighted scoring system that you can implement to prioritize those pain points. And then every single sprint, we take about 30% of our sprint to work on these operational pain points and make sure we're always burning them down. It's tough sometimes for product managers to understand how important it is to do this, but of course, you need to be operating smoothly in order to build new features. So, question, what are the operational pain points? The way to identify that as well is using a mechanism called the Operational Readiness Review. This is something that's part of the well-architected framework, and it simply is a checklist that we have a template out there that you can get. I'll give you a QR code in a minute. But I'd recommend that you build one for your organization, and you ask questions of all of your operations teams to look at these checklists at least annually and before every major release. And you'd be surprised how many times we don't have an answer to the questions that are in there that seem fairly straightforward. Questions about retry and back off strategies, where are your dependencies, and make sure you don't have hard dependencies, those kind of things. Those come up and those get surfaced during an operational readiness review document. How are we throttling customers so that one customer doesn't take down all customers? Common thing that you need to be coding and operating defensively for. And then how well are your alarms tuned, your canary alarms? Are they over-alarming? Are they under-alarming? These are the types of questions that are in there. And again, you can go ahead and download, using this QR code, an operational readiness review template. Again, recommend that you do this with your teams and make it part of your culture, that we absolutely do this every December we do it, and before every major release. So that's one of our best practices. Another thing is around automation. If you can get your team automating 90% of their tasks, which we think is an achievable goal, you're going to free them up to actually work on more impactful things. So this is just a common thing with automation. First, you have to identify the tasks and then build a runbook. Once you have the runbook documented, you figure out which of those tasks can be automated. Not all of them right at the beginning can, but you, again, are constantly iteratively burning down that runbook and try to get it as automated as possible. And I'm going to show you a tool in Systems Manager that helps with automation. Another thing that you need to be worried about is resiliency. And you can see my shirt here says feature flags. Feature flags are a super important tool, and again, we use them very extensively using AWS App Config inside of Amazon, but that's a service that's available to you as well, to make sure that we're operating in a way that keeps our services up. And you might say, well, how does a feature flag help with that? First of all, it is an important difference if the service goes out for 10 seconds versus 10 minutes. Your customers may not notice a 10-second outage. They certainly will notice a 10-minute outage. So if you can get that MTTR down, customers will thank you for it. What feature flags do is it builds dials and switches, operational flags in the software. And your application teams may do this, or maybe your operations team will do this. So it allows you to adjust the behavior of the software on production without deploying any new code. You can just deploy a small change to configuration and tune your application on production, again, without deploying any code. That allows you to move much faster than even a CI/CD pipeline can move. So some examples of flags that we see our customers using. There might be a kill switch for every new capability. You launch something, it sort of behaves well in QA, but not exactly as you expect it. You want to be able to kill it very quickly on production and be able to respond to it and then push out a change later. Throttling limits and allow lists and block lists. You don't want to have to do another code deploy if you have a rogue account out there that's doing some damage. You want to be able to block it right away. And so you do that through a feature flag or an operational flag. Logging verbosity is another thing that we see our customers doing. They want to be able to, during a security incident, crank up the logging frequency so that they can see what's going on. Again, you don't want to have to push out a new code deployment for that. You'll want to push out a small change to a feature flag to increase your logging during that incident. And then things like thread limits. You might want to be able to control how many background tasks or threads are going on. And again, instead of pushing out new code, you can just tune this up and down. All these are things you can do before auto-scaling can kick in. So best practice, build feature flags in your application ahead of time, and that will improve your resiliency. And there's a blog post out there that you can read about how to get started on that. So I'm going to talk to you about a tool here, Systems Manager. Systems Manager is a pretty impressive tool. Again, I'm part of the team, so I'm maybe a little biased here. But these are all the sub-features of Systems Manager, and there's 17 of them. I didn't even list them all here. And most of them are free. Systems Manager is something that you can start to onboard to, and it will grow with you. I wouldn't recommend right at the beginning adopting all 17. But depending on your needs, you're going to pick a couple of them, and I'm going to do a demo of automation and app config to show you. But really, even if your application is on-prem, you can use Systems Manager. If you're hybrid, you can use Systems Manager. And then when you're fully embraced, it's that single pane of glass that will really help you streamline your operations. So I'm going to do, if I can flip over to the demo here. The first thing I'm going to show you is something that just launched 2 days ago. So I'm really excited to show this to you. This is the automation feature inside of Systems Manager. There already was an automation feature, but now there's visual automation that you can build. So I'm just going to very quickly do something here. I'm going to create a runbook, and you can see a drag and drop interface, which is really slick here. I'm going to just grab a sample. We'll do the EC2 sample. And I put this here. Close this up. The screen's a little small. And it has this automation building tool. What we found in talking to customers is they can get up and running in these automated documents, automation documents, much faster using this tool. And so this can be, again, something that, with that goal of automating 90%, this will allow you to get there. So I'm just going to add in something like a sleep command. I need to provide an input about how long I'm going to sleep, 70 seconds, something like that. And it allows you to add things like API commands for EC2 or for whatever service you're putting an automation runbook for. It also allows you to, of course, see this in JSON format or YAML. And I'll click on the sleep and it highlights that. So pretty slick interface for building a lot of automation very quickly. And again, this just launched 2 days ago. And really excited. I think this is going to be a big breakthrough for our customers. The second thing I'm going to show you in Systems Manager are these feature flags. And again, I have a demo set up here with logging verbosity as that example. I'm going to go in and the attribute I have here says that we have 60 writes per second, or sorry, per minute. I'm going to go ahead and edit that now. I'm going to kind of YOLO this and do 60,000. I'm going to go ahead and deploy this to production. Okay, so I'm changing my logging verbosity from 60 times per minute to 60,000. We're going to see what happens. I'll deploy this to production. One of the things that app config has built in is it allows you to gradually deploy things. So I'm going to choose to deploy this over the course of 30 minutes. The reason you want to do that, it's going to deploy to just a small set of hosts, 1% of hosts, then 2%, 10%, et cetera. And it really limits that blast radius of changes. So this configuration also has the ability to have CMK associated with it. So I've encrypted it with my own CMK. You don't have to do that. But I'm going to go ahead and start to deploy this. So what's happening now is it is deploying across 1% of the hosts. And my pager's going off because it caused a problem. A CloudWatch alarm went off, and it automatically rolled back for me. AppConfig has that safeguard in there that it'll automatically roll back a change if it detects an error. So now I'm going to go ahead. That was staged, of course. Let me go back and change this and deploy it without 60,000. Something a little bit more realistic, 120, I mean. Click Save. I'm going to go ahead and deploy that feature flag. Deploy to production. And this time it'll just go, oh, I have to choose that CMK to decrypt. And now it's just going to go ahead and push that off. So that is the end of my demo. If we can go back to the slides. And I'm going to hand it over to Tiago.
Okay, thank you, Steve. So hello, everyone. Thank you for having me here today. Let me talk about all the best practices that those two guys brought up, so how we applied that or rolled it out to Itaú. But first, let me talk about Itaú. So we are almost a centenary bank. We're going to reach the 100 years anniversary next year, so we're really a mark for our history. We are a full-service bank, so we provide end-to-end services to banking experience to our customers. We are the most valuable Latin America brand with $8.7 billion in valuation, and we have 97,000 employees at this moment. So when we decided to start our journey to the cloud, first thing that we had to decide is how to operate, because as we move to the cloud, it's not only adopting a new technology, you have to change how you work. So let me talk about this journey up to the point that we are right now. In 2017 in Brazil, we still were not allowed to run financial services production workloads in public cloud. So we took the decision to start experimenting that with a private cloud strategy. So we started experimenting that, understanding what type of skills we're going to need to change in our teams to operate that at scale. And then we moved to 2018 when the central bank authorized financial services institutions to start using public clouds. So then we start leveraging and starting define our strategy on how to adopt cloud at scale. And then comes the first part of the lesson about cloud operating model. We sat down with AWS and we designed that from scratch, understanding how to change how our teams operate in terms of bring agility to the day-to-day operations, but also how we adapt that, changing the way that our teams, our structure operates, managing the cloud. And now what we are aiming to optimize in that strategy is how we move to a platform operating model, platform and product operating model, where I treat my platform and the services that I provide to the engineers as a product. So I follow the best practices on how to manage those products, engineering products, to our internal customers. So far, here are a few numbers that it's important to mention. We achieved 5.9 thousand certifications. So since we started in 2018, we focused a lot in reskilling the teams. So it's really important to work with the change management process to allow that the team understand and the company as a whole understand that it's important to change not only the way that you operate the cloud, but also how to reskill enabling the team to be successful in their journey adopting the cloud. At the same time, we saw a decrease in number of incidents as we evolved the way that we operate. As we adopt a new practice, best practice in operating the cloud, we saw a reduction of 98% in number of incidents in production that directly impacted our customer experience. And also a 13 times increase in number of deployments or features that we deliver to our customers compared 2018 with 2023. And with our strategy to modernize our workloads, moving from mainframe to the cloud, we achieved 50% of modernization so far. As I mentioned, not only changing the way that you adopt a technology, you have to change the way that you are organized. So we took the decision to change the way that we organize our structure, moving from top down here in the presentation. The enablers team, that it's the two groups down below. It's my team on the left, that is the cloud infrastructure operations, and the solution architecture teams build the platform so the business areas can operate on top of that. What is important here to notice is that we deliver a cloud governance layer to the engineering teams, to the business, so they can operate in a more decentralized way. So the idea here is that a centralized management, but with distributed execution. So you provide information to your engineers that they can take actions and execute on their accounts. All right? So how this reflects, so how our organizational structure reflects to our multi-account strategy. As Greco mentioned, we took the very same the best practice that Greco mentioned and deploy that into our structure. So if you look at here, we are leveraging AWS organizations, so we are providing sandbox accounts for experimentation. The DevOps structure of account structures for refactoring platform, TradOps for rehoster, so lift and shift platforms that we have on-prem that we could not modernize directly for third-party software. We took the decision to build the TradOps platform so we can move accounts, move workloads to those set of accounts and operate in the cloud. And last, think about analytics, so how we can scale data mesh strategies or data analytics strategies using those set of accounts. As we saw, AWS organizations allow us to break down those accounts in what we call condominiums, so the apartments that Steve used as a reference. So each and every apartment here has a set of tenants that works as the workloads that we provide for the engineering teams. And using AWS Control Tower, we can provision as well services here, core services here that for edge services, billing accounts, security, audit logs that is scaled through those set of accounts. Now, let me present to you how we scaled our strategy of scaling the account provisioning at Itaú. So when we started our journey, we defined the strategy where the ITSM would be the first point of entry the front-end services to provision new accounts or request an account. So imagine here that you are a product owner for a new business service and you want to build on top of AWS. You go to the ITSM process, a platform, and you request a new account. But as we are starting to execute or experiment with the cloud, we took the decision to have a human interaction to take the ticket and understand how users were requesting or what type of requests to provision the accounts. So here we have our foundation team being responsible to take that ticket, understand the request, and fire off the request through our automation. Our landing zone, so when we started, we took the decision to use automated landing zone to execute or orchestrate the account provisioning and also the rollout of all the guardrails to the account provisioning process. And also, this allowed us to kick off the pipelines using AWS Code Commit and Code Pipeline to kick off the process to start provisioning the accounts. If you look at on the right side, downside here, we had other teams that could connect to these pipelines and create new guardrails. For example, here, the DevSecOps teams or the CloudSec teams could go there and provide their guardrails for that solution, for that account provisioning process. And once we had the pipeline or structure, we could kick off the account provisioning process as we see here. But as we scaled, we understood that there are some lessons learned here. The centralized pipeline proved to be a bottleneck as the teams were trying to scale and provide new guardrails. So we were stepping in each other's toes, trying to provision those new guardrails to the platform. And also, the lack of autonomy of different teams or different domains. So the foundation team had to orchestrate new changes to the pipeline with its security team. So this kind of orchestration proved to be inefficient as we scaled the platform. And this was hard to scale the guardrails. So we took a lot of time to try to scale the guardrails that we had in this model of account provisioning. So we took a decision to evolve this module based on what we learned. So we took the decision to now start automating with API calls. So now, instead of having a human intervention to provision the accounts, we started using API calls and interacting with AWS Service Catalog. So the same thing as you saw in the previous slide, but now what we took as a decision is we use Event Bridge as an orchestration to provide a pluggable way to other platform teams provision their guardrails. So when you look at here, when we try to provision a new account, we submit events to the Event Bridge so we can push this notification to other teams that can consume the notification of account provisioning and put their guardrails decoupled from one another. And with that, we can start provisioning the accounts, but in a more distributed way. So lessons learned here. So when we decouple the account provisioning process from the guardrails, we could use Event Bridge to provision the extensibility points to the platform teams to create new guardrails without depending on each other. So the orchestration of having the foundation team to connect with the other DevSecOps or SecOps teams was distributed. So we could scale the way that we are provisioning accounts in a more decoupled way. But as we understood with that scale, we saw that as we are scaling the number of accounts, we start facing some challenges with API calls, something that Greco mentioned. We start hitting limits as we was calling several times the API for Service Catalog. So we blocked and was facing throttling from the service. So we took the decision to reorchestrate or re-architect our account provisioning process. So what we took the decision is we build a cellular separation of what we call the control plane and the data plane for account provisioning pipeline. So if you look at here, we created a breakdown of the account provisioning process with the control plane, where we have the API gateway as the input for the request. And also, we break the data plane using control tower as the platform to make the, sorry, let me grab some water here, sorry. Let me roll back a little bit, sorry. So what we did is we used the control plane to separate the concerns around the account provisioning and account management here. So on the right-hand side, we are leveraging AWS Control Tower to be the data plane for account provisioning and be the container or the scaling unit for the account provisioning process. So now when we request a new account, we go to the AWS Control Tower, provision the account, and define the strategy to scale the, sorry everyone. We start scaling just one second. Sorry. We start provisioning the account and using AWS Event Bridge to submit the events or the scaling notification to provision new accounts or add new guardrails. So we start decoupling the scaling units between the control plane and data plane for the platform. This way, we could create new scaling units using the AWS Control Tower, AWS Organizations, and Service Catalog. What were the lessons learned here? The control plane and data plane strategy proved to be very scalable, and we could separate the blast radius of impact if something happens in one set of accounts that we have here. And taking the cellular-based architecture, we could scale out the environment, avoiding service limits, reaching service limits from AWS in this case. And the loosely coupled architecture enabled us to have dedicated onboarding teams to scale the platform and scale the guardrails here. So a few things that we understood. So the pros of this strategy. We understood that we have isolated billing per account. So this way we could have segregate the chargeback from teams as we scale. The business services could have segregated billing accounts that we could charge back them. Reduced blast radius, granular access of the platform, so how we could have separate access to each account and how to define access for each and every engineering team on this platform. And also the dedicated infrastructure for VPC, subnets, logs, and AWS CloudTrail. What was the cons of this? We started to learn that one account per workload was not a good decision. So we scale out to 13,000 accounts so far, which this proved to be a challenge to the platform teams on how we operate and how we execute on a day-to-day basis. The cost of the VPC attachments at scale might be a problem. So you have to think about this when you're using a large set of accounts, might prove to be complex and to manage and to scale. Let me break down here and switch gears, and let's look how we streamline our operations with a real-world scenario with AWS, running on AWS. So here is an example of a digital channel front end that we have on our platform. This serves millions of transactions per day for our internet banking and mobile banking platform. Here's a simplified view of the topology that we have, but some key takeaways from this architecture and what Greco mentioned is we have the DevOps accounts and TradOps accounts routing traffic between each other and even using the on-prem as a backend for some type of integration. So as we moved this workload to the cloud, we understood that there was some challenges to operate and orchestrate all these, the day-to-day operations like patching, environment refresh, environment resize, AMI updates, deployment strategies. So we were pushing that operational efforts to the engineering teams. So this was kind of a huge burden to the engineering teams, and we need to scale that out. So how do we take the decision to scale these best practices in live production environments? We working with AWS, we leverage Systems Manager to provide the automation documents and provide the scalability to fix or to orchestrate those problems, leveraging the systems manager. Based on the example that Steve brought here, we could create, my team as a platform engineering team could create the documents or the automation documents that we could run and fix those problems or the day-to-day operations, and the operations team could consume that in a separate way. So we could break it down from the engineering teams creating new platforms or new automations and the operations teams consuming those services. So how that works in the day-to-day operations. On the right-hand side here, we could see that these are the workloads or the AWS services that we have. And from the platform teams down below here, they were responsible, my team, to publish new documents and push those automation documents to the AWS Systems Manager. And the operations teams run those runbooks through the ITSM platform. So they can push new AMI updates or move traffic away in case of a rainy day. So we have like an outage in certain AZ. The operations team could run those ITSM documents or the systems manager documents through the ITSM portal and make the changes in production without having access to the AWS account. So with that, you can have also total visibility of the changes that is going on in the platform. So logs, audit trail for each and every changes that you have on the platform, you have these tracked down using the AWS Systems Manager. So here you can fix the change ingress traffic, make AMI updates or switch from spot to on-demand instances depending on the demand in that specific region or in that specific zone. AWS zone. So what will be the next steps that we are thinking about? So looking at evolving to the optimized part of the cloud engineering, we are looking at building, change the way that we operate, looking more into a platform engineering strategy. So looking at the personas that you have here, so the Cloud Foundation squads will start building the foundation infrastructure, scaling the foundation or guardrails from the platform. The platform squads that gonna create plugins or stacks, standard stacks for the engineers to work on or to execute on top of that. And the product teams that in business areas will leverage the platform that we call here a stack spot as an enterprise developer platform to build on top of that. So on the left-hand side, you're gonna see that CIOs or business areas can consume from this platform and abstract away the complexity of consuming or building new solutions or new software on top of the AWS, okay? Greco.
Thanks, Thiago. This is an amazing journey. I'm so proud for being part of this in the beginning. Thanks for everything. So we talk about operate models, multi-account strategy, operational readiness review. Thiago brought a lot of lessons learned from Itaú. But remember that everything fails all of the time. So I know that you know this statement and you recognize Werner Vogel's, but remember when you are designing your operating model, remember that you have to recover from failures, right? So just to summarize what we talk about define your operating model, align your operating model with multi-account strategy, centralize your governance, distribute your controls, do operational readiness review, and build future flags to increase your resilience. I want to invite you to go to the CloudOps kiosk. We're going to be there if you want to talk to us. And of course, we do have swags. So you go there, get some swags. That's everything that we have. So thank you so much for being here with us. I would kindly ask you to evaluate our session using your mobile phone. Your opinion about the content is extremely important for us. Thank you so much for being here today. Thank you.